Good day, everyone. My name is Mr. Omo Godwin, and today we are going to learn a very interesting topic in science. It's so fun that we are learning this topic today. Energy, meaning of energy, conversion of energy in base science and technology, but in our sciences today. So, our base science has two arms, science and tech, and we also have PhD. But today we'll be centering on science. It's going to be fun all the way. It promises to be mind-blowing. I am already excited. Are you excited? So let's get to it already, people. Energy, meaning conversion of energy. My name is Mr. Omo Godwin. Now, your objective at the end of the day, I will expect for you to be able to tell me what energy is. Yep. And you can explain the various forms of energy just for me. All right. Okay. So we go. What is energy? So many a time we've been told that energy, just like it is here, it is what? The ability to do work. Yep. Energy is the capacity of a physical system to do work. That is also correct. Yeah. Energy is how things can change or move. For example, you move from one place to another. It is because you have energy to move, and that's why you could initiate such movement. So energy means the ability to do work. Work can be done over time because there's a movement ongoing. It is everywhere around us. Let's not keep it aside. Energy is all around us. We use energy to do all sorts of things, and it takes different forms. There are a lot of forms of energy. It takes energy to cook. That's another form. There's an energy for us to drive to school. There's an energy for us to jump in the air. You can see this girl riding. Okay. There's a lot more to energy than just it is the ability to do work. And that is what we're trying to bring out here today, the various forms of energy around us that we don't know. Like we said earlier, energy requires changing forms of movement, okay? So energy to cook, energy to drive, energy to jump, you need energy for all of those things. Now, the different forms of energy that we have, we'll see them in this lesson. So energy can take different forms. Here are some of the forms of energy. We have heat energy. You can see them here. Is that not so? Potential energy. Is that not so? We'll see all the forms in our science class today. First stop, let's start with chemical energy. This is a form of energy. Chemical energy comes from atoms and molecules. This comes because of the way they react. Chemical energy comes from atoms and molecules and how they react. So we have that form of energy because we have already told you, remember we said, whatever that requires movement, energy has already initiated it. If I move from a place to another, it's because I have energy to move. Yeah. So chemical energy, you can see in your chemical lab, when you go to school and you see scientists mixing chemical up, there's the kind of energy in it. Number 2, we have electrical energy. What did I say? Can you say it one more time? Please don't go near the electricity. Don't go near your fuse, your plug. You may just have the kind of energy you don't want. Alright, so electrical energy is denoted by the movement of electrons. Yeah, there is a movement of electrons. Sometimes you see the spark. You see things. Or sometimes you also hear some sound over high tension wire. Those long poles that you see. You can be hearing some energy transmission over those things. So those are the movement of what? Electrons. Probably we can't see with our eyes. Yes, we cannot see them with our eyes, but they do move. So another form is electrical energy. We've mentioned chemical energy. Now let's talk about heat energy. Heat energy is also called thermal energy. It comes from molecules of different temperatures interacting with themselves. Okay? And under that, we have the greenhouse revolution. For example, these people here, they depend on sun. There's a transparent roof that will absorb energy and it helps them out for their plants. That's what greenhouse does. The solar energy penetrates the greenhouse, but it prevents from escaping. So when energy comes inside, it does not escape. And thus the heat remains inside the greenhouse, keeping the place warm. Do you understand? The energy that is gotten from the sun will go inside the greenhouse and it is trapped there because the solar energy will not allow it to go out, and it helps our plants. They put plants in greenhouses. This is the new modern way of planting and farming. This is a better way of planting and farming. They conserve energy. So this one is part. We also have in heat energy. This is also heat energy. Rocket and the rest. Okay. Then we have light energy. Light is called radiant energy. The earth gets a lot of its energy from the light. And what is the major light? The sun. Yeah, the sun. Imagine if there was no sunlight today. Oh boy, oh girl, really? No sun? Oh God, you may really like the weather and say, oh, the weather is cool. I like the weather, it's cool, but a lot of things will not go well. Plants will not grow. So many things will be hindered. Processes in life will be stopped. All right. So light energy is very important because the sun is a major source of light on planet Earth. Okay. The Earth gets a lot of energy from the sunlight. Also, we have energy in motion. Anything that is moving has energy. This is also called kinetic energy, even from bicycle, humans. Okay, anything that moves is what? It has energy. That's motion energy. The energy is in motion. It is moving. That is what we mean. Such energy moves and they go about. Now, potential energy. This potential energy is energy that is stored. For example, energy, there's energy but it's stored in that object. One example is a spring that is pressed all the way down. Do you know a spring? Have you seen a spring bed before? Let's say something like this. You must have seen spring. By the time you apply pressure here, it comes down. Good. So what we're saying here is that when the spring is pressed down, that time it is down, it is called potential. It doesn't mean that it doesn't have energy. So when you pop it up, wow, what happened? It's going to want to explode. Okay. Another one is a very good example is a book sitting on the shelf. There's energy on that also. You can look at the chart here. There's energy. This potential energy here. Okay. Potential energy on an object. So we human also we use a lot of energy daily. For example, we require energy to drive our cars. We use it for heat, to cool our houses, to watch TV, and a lot more, to even fry eggs and the rest. So energy comes from a variety of places. Where do we get energy from? A lot of places. A lot of this gas, this fan using electrical energy, this solar panel, this electricity, this is what? Windmill. All of them, this Duracell battery. You can see this light energy. So we got energy from various forms. Now, before we wrap it up today, we have renewable and non-renewable energy. Now, non-renewable energy uses up resources that we cannot recreate. These are resources that we cannot recreate. After it is used, oops, forget about it. You cannot recreate them again. Some examples of these are gas to run our car, or coal, like what you're seeing there in that chart, burning in power plants, okay? When you use them, there's no way to renew it. Renew means recreate it again. You can't recreate this stuff. As soon as it's done, it's done. You used up, it's used up. All right, so renewable source of energy. A renewable source of energy is the one that can be replenished. For example, when you have used it, you can get it back again. And this includes like your hydropower from turbines in the dam, your wind power from windmills. Okay, this can generate electricity. I'll show you my last chart how we get our electricity from our dam. Okay, wind power from windmill and solar from the sun. Yes, all these are renewed. They can be renewed again and again. Again, the water doesn't get used up because the air also, we have more of it, isn't it? We use it, but we can take it back again. Now, lastly, before we run through, look at this beautiful chart I want to explain. Now, this is a water pond coming through here. So when the water gets to this side, can you see this turbine? The turbine is what? Is spinning. So when water flows, this is how you get light. And they say during rainy season, we have more of electricity because the water is coming so much. When the water is flowing and the turbine spins, you know what it does? It creates a spark. And this is like a generator. And the generator is going to do what? It hits to the transformer. Watch it, people. It's almost happening. And the transformer is going to transmit electricity to our houses. Wow! So what happens when we don't have much water or when the dams collapse? Then there's problem with what? With what? With electricity. And this is what? Water. Beautiful. So we are using what? Water to generate electricity. And that's a form of energy. Wow, I told you it's going to be wonderful. I know it's going to be great. I have had a wonderful time and I'm also sure you have. Now let's see. Can you define energy for me? Good job. Can you tell me the unit of energy? Unit of energy is joule. Yep. What about the forms of energy? We have chemical. Did I say chemical? Okay. All right. That's nice. Good job. You've done wonderfully well. So from me to you, I would like to say thank you, and please be safe wherever you are. Ensure you do your best and put in your best this season. Thank you for listening. Bye-bye.